Hello everyone, welcome back. Let's talk about another easy problem on lead code today. Take gifts from the richest pile, lead code 2558. In this problem, we are given an integer array gifts denoting the number of gifts in various piles. Every second we do the following. Choose the pile with the maximum number of gifts, and if there is more than one pile with the maximum number of gifts, choose any, and then leave behind the floor of the square root of the number of gifts in the pile. We will see how in a second. Take rest of the gifts and in the end return number of gifts remaining after k seconds. Then in example 1, for the given gifts and k equal to 4, we can take the gifts in following way. In the first second, we will pick up the pile with 100 gifts because that is the pile with maximum number of gifts. So we take that gift and replace it with the floor of the square root of 100, which will be 10. So square root of 100 is 10 and floor of it will also be 10 because it's already an integer. So we replace it and now the pile of gift becomes 25, 64, 9, 4 and 10. Then in the second, we will again take the pile with the maximum number of gifts and this time it is 64. So we take that pile and replace it with pile containing floor of the square root of number of gifts, which is 8. In the third second, we again take the pile with the maximum number of gifts and this time it will be 25. So we pick it and replace it with the floor of the square root of 25, which is 5. And finally, in the fourth second, which is also the last second, we will pick up the maximum gift again from the pile and this time it is 10. And 10's floor of square root will be 3 because when we take square root of 10, we will get 3 dot something, and when we take floor of it, we will get 3 this time. So we replace it with 3. And now we have performed k operations in k seconds. And finally, we have all of these gifts remaining. So the sum of all of these remaining gifts will be equal to 29 and that will be our answer. Then in example 2, for the given gifts and k equal to 4, all the gifts already have a value equal to 1. So if we take a floor of square root of 1, we will again get 1. So we will be replacing 1 with 1. So all the gifts remaining at the end will all be equal to 1. And hence the total number of gifts remaining will be equal to 4 in this case. Now in terms of solution, for the given piles of gifts, we need to track the pile with the maximum gifts and then remove that pile and replace it with the floor of square root of number of gifts in that pile. And which data structure can help us find the maximum element efficiently? And the answer here is Maxheap, because finding the maximum element in the Maxheap takes O of 1 time. But here we have to remove that pile, and for that also heap is super efficient because removing the maximum element from the heap takes log of n time or logarithmic time, where n is number of elements in the heap, and then we have to add back the element to the heap, which will be floor of square root of the number. So that again takes O of log n time. So because of this, Maxheap will be very efficient data structure to solve this problem. Now let's see this in action. Let's take example 1 for that and add all the gift piles to the Maxheap. And now we perform the k operations in k seconds. So we remove the maximum element from the heap, that is 100, and replace it with floor of square root of 100, which is 10. Then in second, we again pick up the maximum element from the heap, which is 64, and replace it with floor of square of 64, which is 8. Then in third second, we will remove maximum element from the heap, which is 25, and replace it with 5. And finally, in the last or fourth second, we will take the maximum element from the heap, which is 10, and replace it with floor of square of 10, which is 3. And finally, the remaining gifts in the max heap are 5, 8, 9, 4 and 3. So we will pull out all the elements from the heap and sum them up. And that will give us 29 as our answer. And now let's jump into the code part. First, let's create a max heap. In Java, we can use priority queue for that. And because it is a max heap, we will be using reverse of natural order by passing in the comparator with values a and b and subtracting the number in reverse order, that is b minus a. Now we will go through all the piles in the gifts array and add them to the max heap. And once we have added all the gift piles, we can start applying k operations on it. So we will run the loop k times. And for each operation, we will pull out the pile with maximum gift count and calculate the remaining gift by taking the square root of the number and rounding it down to the nearest integer. For that, either we can use math.floor or we can directly convert it to integer and add this remaining gift back to the Maxheap. And once we have done the k operations, we will sum up all the remaining gifts in the Maxheap. For that, we will pull out all the elements from the Maxheap and add the gift value to the sum. And in the end, we will return sum as our answer. Now let's submit this code. Cool. In terms of time complexity, it will be O of n plus k log n, where n is number of elements in the array. Because first we build the heap which takes O of n time, and then it takes O of log n for each heap push and pop operation, and we do it k times. So because of this, the time complexity is O of k log n, and overall time complexity is O of n plus k log n. And in terms of space complexity, it will be O of n to store all the array elements in the heap. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.